Thank you for coming. So today we are going to talk about Akka and actor model, as you know, probably. So yes, who am I? My name is Andrzej Janczak. I'm a software developer for about let's say 6 years, mostly JVM based. Fell in love with Scala from the first sight, Scala developer from the 3 years. Currently working in Scala C, so my interest now is like the area that I want to develop myself is like functional programming and distributed system architecture. You can contact me with this email. Okay, so you can ask questions during the presentation, just raise your hand, okay? It will be easier. And the link to the slides will be published on the meetup page, right? So you don't have to, pick up your camera, do a screenshot or something like that. So why this topic? You're probably here because you want to try Akka in your project, yes? You know this is like cool tool, let's say. You heard something about this, but basically you want to know more. So the first encounter with actors is something that, let's say maybe somebody told you that this is very simple, right? So this is only two guys like talking to each other, sending some messages to each other. And like the actor itself, nobody can mutate his state, yes? So you're starting from something like that, and then you go to the Akka documentation, which is quite big, right? And each of these sub-pages is like, let's say, I don't know, 30 pages each, right? So this is a lot of information. And you're going back and looking to a problem, and you have this knowledge on the other side, and the problem is you maybe don't know how to match this thing together, right? So this is what I'm going to talk about today. Yeah, I have a little disclaimer. So a lot of things that I'm going to tell you is in my opinion, yes? So this is some just my thoughts about Akka actor model based on my previous things, right? That I've done. So why this? This is because I'm not going to tell you about something like don't use Java serialization. So this is not yes or no. We are more on the gray scale, right? So we have some problems. We think about the solution, and we want to see how those two things match. Okay. Okay. So first project that I'm going to tell you about is Fields of War. So Fields of War was a game prototype. You can think about this about like Pokemon Go, but with real-time fights. Yes, so a lot of things is happening on the map, right? So you can a lot of fireballs, let's say, can just sway along in the air, right? And the players are attacking to each other, and this is a very like reactive, let's say, system. So it was 3 years ago. It's quite a long time, so some of the things in Akka change. Keep that in mind. And what is important that the communication is via WebSockets, right? So because things are changing so rapidly, so you need a fast way to communicate, right? And 3 years ago is the time of the reactive manifesto. I don't know if you know such a thing, but there was some thought about like the reactive system should be message driven, right? And I think this is like some of the first creators was thinking about when they took like Akka into consideration and actor model, yes? So this was an experiment playground project for the Scala developers. So the basic concept was let's try this Akka in action, right? So it ended up like this. So everything is an actor architecture, right? So messages flying around, everything is an actor. So each service, each controller is an actor, right? This is probably something you never like met before or will meet in the future. Okay, so I promised you some code, right? So the first code that I have for you is the attack service class. So I cannot show you too much because this presentation is not code-based, right? It's more about architecture and how things are connected together, right? But I want to point out some features of that code. So the first feature of the code is that you see this attack service is an actor, right? And he is initialized with only actor ref. So what actor ref is telling you is that this object is an actor ref and you don't know nothing more about this, right? So you don't know what method can you use, right? So these things only give you a handler to another actor, right? Nothing more, no more information. So the basic knowledge that you can get from this code right now is that is name, right? If I would change the player name to the, I don't know, actor 1, you have no information about this, right? You have no idea what it is and what it can do. The only things you can is to throw messages at him. Yes? This is the first feature that I wanted to show you. Another one for this actor is that he is missing some very specific for the actor model, so he is missing a state, right? I'm not going to show you the whole class, but nowhere here you will see the state, yes? So basically something that we can modify in time, so var x equals 1, right? So this actor is stateless, yes? The only thing he is doing is sending messages, have some logic in it, and exchange messages between the other actors. Okay, so next thing I'm going to show you is test case for this, because testing is also a little bit different when you go into the actor world, and you have basically the same concept. You mock things, but everything is also an actor. Mock is an actor, so everything is time-based, right? So you have to think about this, because this is important, and everything here is time-driven. Yes? So you have to sometimes in some specific cases you maybe have to wait. Yes? So expect no messages in 500 milliseconds, right? So this is something that it isn't obvious when you're looking into the documentation, but you may want to have this, and the overall time of for the test running is going to be bigger and bigger and bigger, right? Can be. Next case, okay. Okay. So this is you see the same case, right? So we have a bunch of handlers, but we don't know what they are doing exactly, right? So this is kind of sad thing, but what I wanted to show you here is another feature. Okay, this is the same actor, but this is one of his messages. And you see that he is talking with other actors, right? So he's sending requests to the player service, to the item service, and so on and so on. But what is happening here, if we look into this, we see that the result type is future of any, right? So one more time, we have no idea what this actor is going to produce, right? This is also not the best. So what we are doing is using the map2 function, which is just an instance of. So this is just pure casting, like in Java, right? So this is also not the best situation. The last actor I'm going to show you is player actor. And this actor is different, because this is the first time we are seeing a state, yes? So at the beginning he is uninitialized, but then some messages are coming through, and he is changing his internal state, right? And this actor is also a persistent actor, so he is going to save the events that are coming to him, and he's going to store it in some database so he can recover from failure, right? Okay, sorry, I will not show you more code because it will not give you any advantages. What I will show you that you see like everything here is an actor, okay? So each service, each controller is an actor, so it brings some complications, but I'm going to talk about it later, okay? So this was the fourth code. So first conclusion for the first project. Using a lot of different actors increase system complexity rapidly. Is this a hard diagram? Hard to understand? Rather not. Yes? It's just 8 actors there. Let's say that the mob actor is very complicated, but what is happening in the actor model, he is like boxed. He's chained into the box, and his complexity is not getting out, or shouldn't. So is this statement correct? Still. Well, I didn't tell you about something, right? There's some parts missing, and very, 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 you probably know what it is. This is the communication that is happening between the actors, right? And this is actually what makes the actor complicated, and this system that I showed to you, that's why it's complicated. So your box of complexity, let's say, changed from this one actor to something like that. So to understand some, let's say, basic scenario for the player login, and then some mob is attacking him, it will be difficult, yes, because you have to know something about each of these actor and something about these messages, right? To know what is happening. So I would change its conclusion to the variety of messages between different actors increase system complexity rapidly. Yes, I think this is more true, if you're getting me right. Okay, so second conclusion. Significant amount of services controllers don't need to be an actor. They don't have any state, they don't solve any concurrency problem, so we have no gain from having this as an actor, right? So there was a player actor, mob actor, and probably a few more actors that we have some gains from having these classes, this logic as an actor, but having services or controllers is not so great, right? It only brings kind of complexity to our system. So yeah, another conclusion is that this is not good for prototyping. Yes, fourth was a prototype game, and it's not ended very good. The complexity is equal to the domain complexity and the technology complexity. And the technology complexity in this case is growing rapidly, yes, because of the actors and because of the messages flying around. The last conclusion is that FOV don't scale because he's first of all using event bus that is working only locally. And second thing is that some of the actors hold global states, so you have to make them singleton in cluster, but this is all different distributed world, yeah. And this is tragedy because the system that we have is distributed internally, but we have no advantages gained, right? So we have messages, we have actors, but not big gain is from having this. Okay, so the next project, Bloom. This project was for the external customer of our client. So I cannot tell you everything like in the fourth case, but the basic scenario was something like that. Basic scenario for this application. So we start some virtual machine in cloud, start some tests in this virtual machine, then we have to monitor this virtual machine and those tests. And after all, we do some cleanup, yes? So it sounds very easy, like in these 4 steps, but take into consideration that the point number one can be very complicated. So we are using different virtual machine cloud different virtual cloud providers, like, I don't know, Azure or Google, something else, AWS. They have different API. Sometimes if you just put requests to the cloud, it will give you, I don't know, you request for 50 instances and he will give you 20, yes? And you don't know what happened. And you have to still monitor what's happening and also not to make too many requests, okay? Because sometimes when you do like, I don't know, 100 requests per second, this is too much. So the cloud will tell you, get off, okay? This is too much, I can't handle this. Why actors here? Because a lot of state is here, right? So virtual machine have its state. The test itself is some kind of state. We need to do some waiting and some time-lapsing operation that actors can be good at. So we have this architecture again, everything as an actor, messages flying around, and our expertise was the code was very complicated, yes, because it was not a greenfield project. We have some code legacy there, so the code was complicated, Java in Scala, no functional programming, and some stuff like this. No comments, so somebody was using Akka without understanding it. That was what I'm thinking about this, that somebody was learning the Akka, and code coverage, yes, so no test. So, like, my opinion was that it would be easier to rewrite it than fix it, right? But our client said no, because, you know, they have no time, and they don't want to do this, okay? Yeah, I know this is not the best joke, but I couldn't resist myself. So it basically was fighting bugs over time. Yep. Nothing else, no features, just bugs. And I remember my first day at this project. So I got this code and how to manage this. Yes, the messages are flying around in the logs. I don't see at well what is happening also. So what I did is the sequence diagram. Yes, I think this is the good way to model this kind of behavior, to understand it. Yeah, so what we were doing was debugging without Kibana or anything sophisticated. So the tests were running remotely on some server. Then we have to download it, and it was big, right? It was like gigabytes of strings, right? So we just you cannot open it in Notepad, right? It will hang. You need to have some tools for that. So one thing very important from this project is tracing. So this is thing that also is, let's say, not so exposed in the Akka documentation, but is very important, especially in distributed systems. Let's say the user clicks something, and you should give it a generated ID, and you should propagate it through the whole system, yes, to the end, until he's, I don't know, save something, yes, and all the back forth. This is because if you have a distributed system, you need to know what is happening, yes, and without correct logs, you don't know what is happening inside your system. This is very important. Okay, so summary for this project. It was a good actor candidate, in my opinion, but the execution was not too good. It was too late for us to rescue this application, this project. So basically, we end up with model rewritten, but not in Scala Akka, probably. But I don't know what happened after we left. So conclusions. Decision about taking actor dictated with hype, probably, not with knowledge. Yes. So I think that they just read some blog posts on the internet, and yeah, let's try this Akka, right? So this is approach that we could live it, but in FOF, the first project, because it was experimental, and it was a game prototype, right? But here, doing something for client, I don't know who's taking this kind of decisions, right? So it was a very bad mix of no Scala experience, no Akka experience, and no time for learning, right? So this is a very bad combination. And the time is underlined because of this. So let's get back to year 1973 now, okay? So the bunch of guys decided to do a new language, do the actor model, let's say, yeah? So they close the door, go to the other room, go outside the mainstream, and do their thing, yes? So why they did this is because every solution that was available for them was not good. So these were guys from the telecommunication, so a lot of threats, a lot of state, and they didn't want to use kind of locking mutex. This were not good for them, okay? So they abandoned this, closed the door, go to the other room, and doing actor model, doing Erlang, right? And they're doing it for over 40 years, right? Look at the gap. So if you're thinking that you can, minimize it by coming here, right? And you're going to be Akka expert in one night, this won't happen. It's impossible, right? If you want to do something good with Akka, you probably should go look to the papers for the Erlang and for the actor model first, right? And this is very important because we are lack of this knowledge, right? I think for most of us, actor model is something very new, right? Something we weren't prepared by studies. So the project number 3, the Hunter, you probably know this one. No, this time is not everything as an actor model, but Hunt is like, you can think of it like CRUD++. So this is just some web server application. We use Play framework there and some basic database. So we needed some simple cache, but this was not scenario of for the web cache or for DB cache. So it was kind of specific and defined problem. We didn't want to use any library or any synchronization because we don't know trust like this one, okay? So we decided to take actors, right? So it's basic natural concept for me that nobody can mutate my stuff inside me, yes? So if you take this, something like this, you can explain it to the 5-year-old probably, right? He will be able to understand it. So if you use the actor advantages, so only I can mutate my stuff and only somebody can, communicate with me only by messages. So this is very simple, in my opinion, right? And your actor is tamed, let's say. He's kept in box, right? So the 4th project, okay, this is probably the biggest one. In this project there was a very big desire of the scalability and distribution. We use microservices, event sourcing, CQRS, Akka persistence, Akka cluster, Cassandra, and Akka stream. Okay, so let's see how was it going. This is the diagram for the basic diagram of the architecture, right? So we have just a regular controller, regular service. This is not an actor, so this first 2. Here we have something new. Akka cluster, it's sharding, right? I forgot about this. This should be in each of these boxes. So Akka cluster sharding is providing you some mechanism to let's say create actors here or here, okay? And the best thing is you don't have to know, you don't have to care about these ones, okay? Where they are going to be created and where they are going to be live, okay? So the first scenario is we want to modify the actor number 1, okay? So this is easy. We go to the controller, to the service level, then to the Akka cluster, yes? We say to the Akka cluster, hey, send some message to the actor number 1, right? And what he's doing, so I'm not going to dive into Akka cluster sharding internals, but he's sending a message to the actor number 1, okay? And this actor is a persistent actor, and he is going to store some data in database like Cassandra, right? So this is simple. We have 2 nodes in this architecture. Okay, so let's look at the second scenario. Okay, so now we want to modify the guy number 2, right? Okay, but if we have some kind of load balancer there, so load balancer is stupid. He don't know where the actor lives, right? So what he's doing, he's sending the message to the same node number 1. The message is going to the controller, to the service, and to the Akka cluster. But Akka cluster is know, through its features, it's know that the actor is not on this node, not on this machine, but on this, right? So he propagates the message to the actor number 2. And the same thing happened. The actor number 2 is storing his state in the Cassandra database. Everything is fine, right? So what we achieved here is location transparency. Look that we don't care where those actors live. Yeah? Akka clustering do this for us, right? We don't care if it's going to be created on this node, or some other node, yes? We just don't care about this. And this is a great thing. Let's say that one of the nodes failed, right? So we have no connection to him. But what is happening, the actor number 2 can recover in the node number 1, yes? He was before on the node 2, but he can easily recover his state on the node number 2. This is done by some Akka cluster sharding magic that I'm not going to dive into because it's it's for another presentation. Yeah, it's very big topic. Okay, so the TQRS. I forgot about saying you that this one is command side. Yes, so you probably maybe heard the TQRS model before. So this is command query separation. So the command side should be totally separated from the query side. Yes, this is this concept. So here we have the command side, right? And now I'm going to talk to you about the query side. So if the side should be separated, we have to do something different, right? So let's say that we have a different scenario. So now your case is that you want to filter by customer name, let's say, right? So what is happening, you have to do something different, because if you would like to done it only by Akka, so you would have to send message to each of these, right? Get their state and then do a filtering somewhere here, right? This is not smart thing to do, because let's say that the actors are in millions, right? The instances of the actors, millions. There are millions of them. And what you have to do is to take another approach, yes? So what you are doing is building a query model. So this side here on the bottom is query model. What we are doing in the first step is taking the data, the events that was stored before, right? Here in these cases, and put it to the Postgres or some other database that is good at filtering what you need. This might be anything, right? Not only Postgres. And we done that by Akka streams, right? So the Akka stream, what is doing, it have a cool word for it. this is back pressure, right? So we are taking the events from the Cassandra as fast as we can and take it to the Postgres as fast as Postgres can do writes, right? Because Cassandra is good at writing side, yes? He accepts a lot of requests at once, but Cassandra is not good at like the query model, let's say, so they're not good for the filtering, right? And what is good for the filtering is Postgres, right? That we use, let's say, Postgres here, and we store the data here in some different like modification in tables. Yes, here are just some events. Here is the current state, because please notice this is not a current state. We have some time limitations, right? So this is called eventual consistency. So before we store the data to the Postgres, we're gonna need some time, right? This is very different. It depends on how much data you have to push through the Akka stream and your project basically. But you have to remember about that the query side is eventual consistency. Yes, we have some latency between this state here that is events that are facts, that is something like that happened and is stored here. Yes, this is later. This all here is in some future, right? So this is not in the same state. The bottom and the top of the diagram are in different time zones, let's say. Okay? So you can add to this some Spark or some machine learning, and you can go to your boss and say, hey, this is great architecture, you can use it, right? So now you have all the things that you need. So some summary. Okay. So what this architecture gave us is location transparency. We no longer have to think about where the actor is going to be created. Another feature is easy scalability, because we only add another node, and creating of these actors is out of our scope of interest, right? So we don't care about this. This is scalability is for free, basically. So not failure resilience, I show you this, also network. This is more thanks for the Akka, right? Akka cluster sharding. So strong consistency on the right side. Yeah, this is something that I skipped, so I'm going to be back. So what persistent actor do before he mutates his state, right, over here in memory, he first save some events, some data to the database, yes? And he's waiting. He's waiting until he's getting a response to that one that the data was saved, right? So in that way we know that this part is consistent all the time, right? If we take into consideration that Cassandra can be also easily replicated and scaled, so the system is quite resilient, okay? Okay, and in my opinion, achieving this is not so hard. So you have to produce more code, yes, because there are some new parts here, like this loader. But the customer control you have to write, customer service you have to write by yourself. Akka cluster is basically like for free, let's say. This one you write by yourself, this persistent actors. And the query side, yes, it's a little bit different, and you have to handle the extra database model, right? So it's more code to write, yes, but if you need it, if you need a performance, if you need scalability, I think this is like one of the good solutions for that. So more code, so the minus part, more code, more parts to manage, and the eventual consistency on the query part. Okay, so this is all that I have to tell you about the project. Now few slides about the future of actors, right? So right now the actors are untyped. So as I showed you in the first project, there was messages flying around, but all the Akka API is untyped. So you have future of any, or you send messages of any to someone, yes? And all you have is actor reference, like here, but it's only an actor reference, right? It was without this one. And what is going to happen in future? Actually, this is this code. You can use it. It's already there, but it's experimental. So the API of this can change, right? So if you want to use it on the production, well, you can take a risk. It's your game, right? So what is changing here? The actor ref is typed, as you see. So now we know now we know exactly what is going into our actor. Yes, the messages are typed, and everything is specified more. You see that the sending is moreover the same, right? But what you have from this is like what you want, what we like in Scala world, right? So we like types. We like to know what is going to happen, right? There. But this is not the biggest breakthrough. One important one is what's going to happen further. Okay, so so if you have these typed actors and you want to send messages to them, you can do this the normal way, like this, by the send operator. But you can also write something. Well, actually, this is not ready. So I think you cannot use it. This is not in the part of the Akka, but I hope it will be in the future. So what is going on here is that you write some operations, right? So now you can tell that you want to first authorize something, send it to another actor, wait for the response, send something different, and wait for the response. Yes. So the messages and the messages flow that was hidden, that was covered in the project number 1, now is visible and is documented, and all is typed. Yes. So this is something that Karol is going to talk about. So this using shapeless. Yes, and it's all typed. Yes. Here we have all the type support we want. This is part of the roll and count presentation. You can watch it here. Okay, so I don't want to left you empty-handed, right? So I cannot give you any code, but I can direct you to some repositories. One of these repository, the first one, Ethereum client in Scala, have a lot of different actors, a lot of different messages, so you can watch there how well, I don't know if this is the exact same structure as in the first project, so actors everywhere.
No, it's not.
It's not? Okay, so it's better, but you have a lot of actors, yeah. A lot of messages flying around. So it's open source. My colleague doing this, so it's I think this is worth to see it. But spoiler alert, this is quite complicated domain. Yes?
It is.
It is, because it's blockchain, right? So you can do this. The second one is about Akka cluster with persistent, and this presentation is focused on the comparison on the performance with normal CRUD application, right? So you can see you can see the presentation and go through the code and run by itself. The third one is also like the same. It's using Akka cluster and with Akka persistence, and it's very easy to run. So if you want to know more about this architecture and how it like scale and behave, so you can just run it. It's very easy to run, this third one. And the last one is Apache Flink. Well, basically they decided to use that for the communication. But I saw the code and it's not the best one, because I think there are mostly programmers from Java world and they were trying to use that, so I don't recommend this as a role model. So keep calm and wait for Akka. No, this is not the end. I do have some recommendations for you, yes, some summary. So basically I don't recommend you to do everything as an architecture right now. So in this case, actually you can't wait for the Akka type, yes? Because probably this is not what you want. Think of the cost that I show you. So the messages flying around, keep it at mind. And you need a really strong argument if you wanted to do it, right? You should discuss it with somebody, with your colleague, about the architecture that you're going to do and why you are choosing Akka, and decide it together, right? Because maybe if you take Akka, you think this is great idea and I would love to use Akka, but maybe take a deep breath and think about it one more time. So use second one, use Akka as a tool, not as a framework. So Akka can be hard to tame, right? And it's hard to, it's sometimes hard to use because you have some problems, you're looking for some kind of solution, and you can use Akka in too many regions of your application, of your system. So what you want to do is to tame actors, yes? So if you're in a situation that you're feeling that actors are owning you, I think this is not a good position, right? You should take a step back. Yes, so think twice when your actor don't have state, don't solve any concurrency problem, don't solve async communication, or don't solve any other distribution problem. So this is definitely an orange light, yes? So these things, think twice. Yes, you see that you don't have state, you don't have concurrency solve, the Akka is not helping you in any way for your system to be distributed. So think about it twice. This is an orange light. Akka is rather good for defined and specific problems, right? So look at the first project FOF. It was a prototype, everything was changing there, different concept, different ideas, everything was still changing, right? But in on the third project in Handley, when you wanted just a cache, so you know what you want to achieve, you know what exactly you want to do, you know exactly what is your problem, and this is where we decided to use it. This is why we decided to use it then, okay? So if you don't know what your problem is, how you can pick up the right solution, right? And taking Akka into consideration is really something you have to think about before doing it, right? Before starting the actual work with Akka. So Akka use it good, wisely, can be a rescue. I think this is a powerful tool, very powerful tool, a lot of different stuff, so distribution, persistency, clustering, a lot of different features in Akka. So a lot of advantages also with quite low cost, right? So look at the last project, right? We add some more code, but the boxes were still small, right? So here we had a persistent actor, here we have service, and everything is quite nice, yes? So it don't get over all your system. And this can only get better, right? Sorry, only gets better because the Akka type is coming, the formal protocols that I show you are coming, and probably more even interesting and more advanced features are coming in Akka. Bonus slide, we tested Akka streams in production, so it have advantages over the Akka Actors. They are typed, and right now they are typed. So back pressures, I was talking about back pressures. A lot of connectors, so you connect it to Cassandra, Kafka, whatever you want, and definitely easier to start, right? So this is a good place. And yes, so the final question, to Akka or not to Akka? Well, it's an architecture discussion, right? So each project is different, each case is different, each system is different, right? So we have to look at your problems, remember about what I told you about the problems you have and the solutions. If they cover up good, if you think this might work for you, then use it, yes? Probably you don't want the everything as is an actor architecture, right? Because you've seen that in the project number 1. The messages were just flying. You don't know what's happening. If you go to this project, if you go into this project and you don't know what's happening there, you have to take a piece of paper and write a sequence diagram, yes, of the communication, what is happening there. Yeah, so this is a lot of powerful framework, very powerful framework. Akka is very powerful, but with great power comes great responsibility. Thank you for your attention.